So in a lot of ways, what we're going to be doing now is a review of our first chapter. Okay? If you wanted to graph y equals 2/3 sine x, this 2/3, would we say that's inside the function or outside of the function? Would it be vertical or horizontal? Right? It's outside. This is going to be a vertical compression. You're going to multiply your y values by 2/3. So the graphs that we made on Thursday of last week, do you remember? Do you remember the graph of sine, the graph of cosine, and the graph of tangent? These are our new parent graphs that we have to do all the graphing from before. Now, we're going to find out that for these graphs, there are some shortcuts that we can use, and we're going to start using them right away. So for this first example, you know what your sine graph looks like, and this will multiply all of your y values by 2/3. So on your graph, it doesn't affect your x values. And on our x values, we always did the axis family, so do pi over 2 and split it into 4 sections. Pi over 2, pi, 3 pi over 2, and 2 pi. Since this is a vertical compression, that doesn't affect our horizontal values. Our sine graph started in the middle, and so these points that were on the middle where the y value is 0, can you see that they also will not be changed? Because when you multiply 0 by 2/3, they're going to stay 0. The big point that's going to change is the maximum. The maximum was at 1, but if it was at 1 and you multiply it by 2/3, can you see that now it's going to be at 2/3? And the minimum was at -1, but now will be at -2/3. So since we had a vertical compression, the only thing that really changed was the amplitude. And the amplitude is the measurement from the center to a maximum or the center to the minimum. What's this distance? It was 1, but since we compressed it, it's now 2/3. So as a shortcut, we're going to find out that the number in front of sine or cosine is the amplitude. So in B, already, I can tell you that the amplitude is going to be 4. Amplitude is always a positive number because it's the distance from the center line to the maximum. So even though there's a -4 in front, I already know that the amplitude is going to be 4. So I'm going to part B. Again, this is outside of the function, so I would call this a vertical reflection and this a vertical stretch. Together, we're going to multiply our y values by -4. Again, your y values are changing, so when I go to graph this, I'm still going to split this up into my axes family. Pi over 2, pi, 3 pi over 2, and 2 pi. But instead of having 1 and -1, because my amplitude is 4, it'll go up to 4 and down to -1. Now your regular cos graph, this is what you got to think about. My regular cos graph looks like this. Starts at 1, goes down to -1, from 0 to 2 pi. That's my regular coast graph. Can you see that if you have a vertical reflection, instead of starting at a maximum, a vertical reflection would cause it to start at a minimum? And another shortcut that we're going to learn for this unit for graphing is once you have your 4 sections drawn, in this case from 0 to 2 pi, when you graph a sine or a cosine graph, and you have a point to start with, and I have the minimum, next it'll go to the center line, then to the maximum, then to the center line, back to the minimum. And that'll be a shortcut for us to draw these. So, you know how in transformations we often did a certain point and then did arrows? We're going to skip that step for a lot of our trig ones because we can do it faster. What's our amplitude? So even though there's a negative outside in front of this equation, we always talk about amplitude with a positive number. So step 1 for shortcuts for sine and cosine graphs is that the number in front, in other words, a vertical stretch or vertical compression, will always equal the amplitude. So this one we have a 4 out in front, the amplitude is 4. First one we had a 2/3 out in front, the amplitude is 2/3. Is everybody done drawing? Okay? I'm going to get you to write down the questions and circle them. 3A and B. 4, 5, and 9.